Here is another simple question. In this case, we have two resistors in parallel, R2 and R3, and we are asked to find the current through the battery. That's the current here. You know that this current, as it meets the branch in here, some of it is going to go through R2, that we are going to call I2, and some of it is going to go through R3, we are going to call I3. Now, I would like you to notice something else. The colors here were purposely put to emphasize that orangish wire or color designates a place where I have the same electrical potential. In this case, 60 volts. The red one designates the locations in the circuit where I have the same 0 volts electrical potential. Now, what this is reminding us of is the fact that R2 and R3 are in parallel with the battery, so the voltage across all three is 60 volts, or the voltage difference across all three is 60 volts, which says that VR2 is 60 volts and VR3 is 60 volts. But both of these are given by Ohm's law. VR2 is R2 times, R2 times I2, and VR3 is going to be R3 times I3. So you notice here I can find an I2 and I3 very easily. So I2 is going to be equal to VR2 over R2. So in this case, it's going to be 60 volts over 20 ohms. So that gives us 3 amps. Now for I3 is VR3 over R3. And in this case, it's 60 volts over 30 ohms. And that gives us 2 amps. So I2 is 3 amps, I3 is 3 amps. Because of conservation of charge, both of those should add up to I. So I is just I2 plus I3. It is equal to 5 amps. Okay, let's work on another question where there is a slightly added complication. What we do have here, one resistor R1 and R2 and R3. R2 and R3 are in parallel, but neither one of them is in series with R1. And the question is asking us to find the current through each of the resistors. The rule, as always, is to try to simplify the circuit if we can in the beginning. We try to find the current through the battery, which is going to be the same as the current through R1, and then we backtrack to find the current through each of the resistors. Okay, let's explain that. Now, if we designate the current here as I1, the current going through R1, it is the same as the current through the battery since they are in the same branch. Now, as the current meets this junction point, it's going to be divided into two components. One part is going to go through R2 that we are going to designate by I2, and one part is going to go through R3 and we are going to designate it as I3. Okay, now the question is asking us to find all three. What I'm saying, before doing that, we try to simplify the circuit. How do we simplify the circuit? First, we notice that these two resistors in parallel, R2 and R3. So we try to find their equivalent, R23. Since they are in parallel, we know that 1 over R23 is going to be equal to 1 over R2 plus 1 over R3. Now, writing that down, that's going to make it 1 over 20 ohms plus 1 over 30 ohms. Putting these in the same denominator, I'm going to multiply the first term by 3. That makes it 3 over 60 ohms, plus multiplying the second by 2. That makes it 2 over 60 ohms. The overall is then 5 over 60 ohms, and that means R23 is equal to 60 ohms over 5, or just 12 ohms. So we found R23. Now that we found R23, my circuit is then simply E R1 and R23. Notice now that R1 and R23 are in series. We have the same current going through both of them, which is I1. Now, since they are in series, we can combine them, saying R123 is equal to R1 plus R23, which is 10 ohms plus 12 ohms, which is 22 ohms. Now, my circuit is the even simpler circuit now. This is my E, which is 44 volts, and R123. I still have the same current I1 here, coming out of the battery. Now, from this first circuit, I can write that the voltage across R123 is the same as the voltage across the battery. Is equal to E is equal to 44 volts. But then that's also given by Ohm's law, which is R123 times I1. So I1 is going to be equal to 44 volts over 22 ohms, which is R123, which is 2 amps. Now we found the first current we are asked to find. To find the second and third currents, what we need to remember is the current I1 is the same as in this circuit, which means we can find the voltage across R23. Voltage across R23 should be the same as the voltage across R2, which should be the same as the voltage across R3, since R2 and R3 are in parallel. And that's given by Ohm's law, which is R23 times I1. Since I1 is 2 amps, and R23, we found it as 12 ohms here, so that makes it 12 ohms times 2 amps. That makes it as 24 volts. Now, like we did the previous problem, I2 is going to be VR2 over R2, and in this case that's going to be 24 volts over 20 ohms. That makes it as 1.2 amps. And then I can find I3. I'm going to write it on top here for the space. I3 is equal to VR3 over R3, which is going to be, again, the 24 volts over 30 ohms, which is, in this case, 0.8 amps. And you notice the 0.8 and the 1.2, they add up to the 2 amps, as we expect them to.